Garbage dumped by the roadside, garbage overflowing from drains, garbage floating on our water bodies. These are common sights across India. Have you ever wondered where most of our waste goes? Well, 94% of our waste is untreated. It's not dealt with safely. It's either burnt or dumped at landfills like this one. Once one landfill is complete, a new landfill is sought. Most of the waste here at these landfills is not recycled, and you have hazardous waste lying right next to organic waste. I'm Manvi Dhillon, and you're watching DuPont Presents The Power of Shunya, Quest for Zero. And today we're asking, can science and technology be used to reverse this waste management crisis? And can waste actually be converted into a resource? And now Ravi Agarwal of Toxic Links helps us understand the magnitude of the waste management problem. I can't even begin to imagine how much waste India generates. This is just one small informal segregation site, and we can see what we can see. How much waste does India generate?
Well, there's a number of kinds of data, but let's say that we can generate about 190,000 tons per day, which comes to about 70 million tons per year. But this has become almost 8 to 10-fold in the last 10 years. So it was 10 times less. And in the next 10 years or 15 years, it will become 2.5 times more. So we are looking at, by the end of the decade, about 180 million tons of waste per year generated in India. It's a huge amount. And if you accumulate all that, we have to deal with about 1,000 million tons of waste the next 10 to 15 years.
What are the biggest challenges to effective waste management? Because when you're talking about quantities like that and no really clear, cohesive plan in place, it seems like a really tough job.
So it's a huge, huge amount we're talking about, and our municipalities and our infrastructure is just not capable of dealing with it. But we're not dealing it as a national mission. So, in a city, in a new urban setting, waste will become the biggest problem. Because it's not just what you see, it has so many impacts. It has impacts on your groundwater, on the toxicity of the food we eat. It has impacts on climate change, because if you burn it, you'll have carbon dioxide, you have methane coming out from landfills. So it has a huge, huge impact. But we're still dealing with it in its narrow, small ways. So that's a big mindset we need to go through in saying we're dealing with a really, really big problem here.
What is the role, to your mind, that science and technology can play in waste management? Our show is focusing on the science and technology aspect in solving our waste issues, but how big a role do you see science and tech playing?
I think it has a huge role because, all the solutions we look for are from Europe and from North America. These are not appropriate to our conditions or to the kind of waste we generate. There has been no parallel in the history of the world where a country like this has started creating so much waste in such a short time. We don't have to create basic science, but we need to innovate. We need to innovate solutions. And that's where the science and technology can play a huge role. Conversion of waste, processing of waste safely is another place where we can innovate. So we have to look back into ourselves and saying what is the appropriate innovation from them. And I'm telling you, we'll be world leaders. We'll export to all the developing countries, including to China, if we manage to do that.
India consumes 11 million tons of plastic every year, against a global consumption of 275 million tons. Plastic and polymer consumption is growing at an average rate of 10%. 99% of all plastics are made from petroleum byproducts and take about 1,000 years to decompose. It's safe to say we're sitting on a plastic time bomb. India generates 56 lakh tons of plastic waste every year. The big cities are the major culprits, with Delhi producing 690 tons of plastic waste every day. Chennai, 429 tons a day. Kolkata, 426 tons a day. Mumbai, 408 tons a day. Not only does the production of plastic impact our environment in terms of recyclability and biodegradability, but it also puts a strain on our already diminishing fossil fuel resources. If plastic waste dominates over land and water, then giving it stiff competition is this weed, water hyacinth, swiftly taking over our fresh water bodies.
It actually takes over the entire water surface, and it is very intelligent weed actually. It grabs all nutrient, utilize it very sustainably, and then grow in biomass quickly. So when you have biomass, it covers everything. When there is no light penetrating to the water, then you look at the quality of water. The quality of water goes so down, oxygen level dips, and therefore no aquatic animal. Even phytoplankton and other aquatic plants cannot survive.
But Professor Murugesan in Alvarkurichi, Tamil Nadu, has found a unique solution to both the problems. His years of research have helped him extract biopolymer from water hyacinth. The end product is biodegradable plastic.
I was working on water hyacinth for the past 3 decades. I worked on the utilization of this weed for depolluting contaminated water. Then I thought of doing something on the controlling this water hyacinth. I worked on the biological control using some weevils, and successfully I have demonstrated at field level. And next thing is I started working on the water hyacinth for polymer production 8 years earlier. Initially I worked up to the conical flask level without any fermenter and other facilities. I was able to get the polymer in test tubes in milligrams. Now I came to the level that I am able to produce several grams of polymer in my lab itself.
Extraction of biopolymer from this weed is possibly the first step towards zero plastic waste.
So I processed the water hyacinth leaves, and they were cut into pieces, dried in shade for 3 days. So after 3 days, this was made into a powder. This is the powder of this water hyacinth. So I have to remove the lignin first.
Okay.
So for that, I use sodium hydroxide to delignify the material.
Okay.
Adding sodium hydroxide gives a liquid like this. So I have to filter this.
So that's the residue that you're now going to be treating further.
So this residue, now I dry it at 50 degrees centigrade overnight, and I got this powder again.
Okay.
So this now I have to make some acid hydrolysis. I am using hydrochloric acid. This is the filtrate.
And after a few more steps, the result is for all to see.
This PHP, this is the polyhydrous butyrate. We have to add some copolymers and additives to get the required shapes. So we can use carry bags, shopping bags, razors, pens, like that you can use.
So you're motivated to make the use and throw items out of this biopolymer because those are the ones that leave a huge footprint on our planet. Can you get it from sources other than the water hyacinth?
In market, in other countries, they are making this polymer using rice flour, sorghum flour, sea maize flour. But we are interfering with the feedstock of the livestock or human beings. But these aquatic weeds or other agro waste we use, we are not competing with the feedstock of the human beings or other animals, etc.
By turning a weed like water hyacinth into a resource, Professor Murugesan is hopeful that the problem of plastic waste can be weeded out. To get a biopolymer out of the water hyacinth will help us achieve our aim of zero plastic waste.
Certainly, madam. Yes, now people now only they are thinking about alternatives for the already available market available plastics. So now these findings, when findings are going to the government or some entrepreneurs, definitely they are thinking about that.
Today we've seen how science can take a weed and convert it into biodegradable plastic. After the break, we'll meet a scientist who's found a sustainable way to treat used water. DuPont presents The Power of Shunya, Quest for Zero. We'll be back in a moment. Domestic waste, industrial toxins, agricultural residue. There's no doubt that our rivers are highly polluted, and some, like the Yamuna, are even dying because of wastewater contamination. It is estimated that less than 20% of domestic wastewater and 60% of industrial wastewater is treated. That's too low. Inaction is no longer an option. Is there a science to reducing the amount of wastewater that ultimately resides in our precious water bodies? Can we repurpose this waste in a more progressive and sustainable way? Or perhaps some answers lie with the fine particle thrombostyle reactor. Wastewater contamination is a major cause of concern. 70% of industrial waste is dumped without treatment. India alone discharges 48,797 million cubic meters of wastewater every year. Each litre of wastewater discharged further pollutes about 5 to 8 litres of fresh water. What if we had a technology that brings about a complete wastewater recovery without the use of chemicals? Dr. Raja Vijaykumar, a scientist from the city of Bengaluru, chanced upon an innovative idea. And the result? The fine particle thrombostyle reactor. Can you drive home some hard truths about wastewater, poor management of wastewater in India?
Industries are the biggest wasters of water. Okay, but then you cannot shut down industries because it uses water.
Right.
So you have to find out a solution that is beneficial for both the industry as well as to the environment. You have to strike a balance somewhere. Today the problem is that the concept of recycling, reusing and recovering the water is not very popular in our country, and to some extent it is a little bit popular in some of the Western countries. But then still a lot needs to be done in this area before we can say that we are zero in wasting water.
The fine particle thrombostyle reactor is an automatic computer-controlled reactor that uses high-intensity shortwave resonance to get rid of impurities. It's based on the principles of blood clotting in our body, technically known as the thrombostyle reaction.
Thrombus is formed when number of particles aggregate together, okay, and join together to make a bigger particles. All particles in water, dissolved in water, they are together with the clusters of water, and all particles are charged. They are charged on the outer surface with negative charges, and you have the inner core as a positive charge. So the idea is, if you would increase the positive charge onto it, the negative charges will collapse and these particles become chargeless. When they become chargeless, they all attract together because there is what's called a van der Waals force, which pulls all the particles together, and then you get all these solids into a lump, and the water is separated out very neatly. So it's then can be kind of filtered with any kind of filtering system.
What then become the unique features of your reactor?
One is you don't use chemicals. Okay. Then second is it consumes less energy. Third thing is you clean up water at a very low cost.
200 kilometers from Bengaluru, the Kodagu district is home to many sprawling coffee plantations. Dr. Kumar's fine particle thrombus reactor is doing its job in this coffee processing industry. The state-of-the-art technology converts all the coffee wash wastewater into processed water.
In the coffee industry, to process 1 kilogram of coffee bean, you need approximately 36 liters of water. So that's a huge amount of water that goes in for making a kilogram of coffee. Now the idea is to reduce this. For that being the objective, we wanted to put this plant here. This is a pilot plant which processes 25,000 liters a day, and the water which comes out is as good as water which we can drink, and this water can be reused in the process. That way there is no water discharge from the process, from the pulping process, which otherwise for every kilogram of coffee you have to discharge about 36 liters of water. So this would drastically bring down few things. One is the carbon footprint of the process. Second, the water requirement of the process from the point of view of wastage, and this is a great advantage to the industry.
A patented process that has the potential to effectively and economically treat wastewater and reuse it. The fine particle thrombus reactor is on a quest to achieve zero wastewater.
The very fact of this invention is that we wanted to recover water and recycle it into the system, so that what finally goes into the environment is as least as possible. So by this technology, when properly implemented, I think we can solve almost 95% of wasted water problems, and in both small scales as well as large scales. You can this one technology there where you can you can solve problems of small polluters with not spending much of their money. So these are some of the things which we can think of from looking at from the point of view of the Shunya of wastewater.
Well, today we've seen two innovations that are working and striving towards the concept of Shunya by reducing the amount of waste that goes waste. For final thoughts, we turn once again to Ravi Agarwal, Director at Toxic Links. Ravi, two separate concepts, we tend to muddle them. One is trying to decrease the amount of waste we generate, and the other is to actually manage the waste we generate more effectively. Is that distinction important, and any advice that you would give on both sides?
I think these are very important thoughts to keep in place. So reducing waste, that means minimize waste at all levels. So how you do your packaging and how you what you do with the packaging at home. This has to be constantly part of your thought of sustainable waste management, no matter how much waste you're generating. So if you have a glass bottle, would you want to throw it or want to reuse it? When you're creating new packaging in industry, what kind of packaging will you create? Something which can be recycled, you minimize the packaging for the purpose it serves, or you want to have this huge packaging with a small little product coming out, a box that size. So these have to be kept in the mind. And once you do generate the waste, and not call it waste, call it separated materials, then you have to manage it. So they are not inconsistent with each other. Together they form the basis of sustainable waste management.
Converting waste into usable resources, do you see enough thought and action on that front in India?
In fact, there is actually very little thought on this, except in this kind of location where people are making a living of what they can. But this is cherry picking. They are recycling what has a market. But what happens to those materials which have no market? Like you see a lot of these materials, plastics lying here, which cannot be recycled. Or you have materials which have high degree of toxicity, like heavy metals in them or other chemicals in them. Even if you recycle them, they cause a lot of problems. So electronics, old electronics, if you recycle them and create new buckets, those buckets are the same chemicals the old electronics had. So this has to be done with proper thought. And this is very much part of how product designs have to be made and how recycling systems have to be set up. So if you have safe plastics without chemicals, you can easily recycle them. You don't need all these emission norms to recycle them. If you don't have them, you have to have this huge regulatory system to look at what emissions they're releasing and stopping the emissions, and then what comes out of those emissions you have to dump somewhere. So it's an endless cycle.
So set the standards at the point of origin and it makes the job that much easier down the chain.
What we call cradle to grave in all senses.
This show is called The Power of Shunya, Quest for Zero. Is it really too optimistic to imagine in India with zero waste or zero unrecycled waste?
No, I think, Shunya itself is a concept which this country gave to the world. So the idea of Shunya itself means that it is doable. It's the idea of infinite in Shunya. So this is a country which lives in optimism, in a sense. I think it's completely doable. It needs everybody to get their act together at a micro level and at a macro level as well. And it is completely achievable. There is no problem in that. But as I said, we need to think of the scale at which we're dealing with. So scale should not overwhelm. It just means the collective individual responsibility which aggregates into the scale. That needs to be thought of.
Waste management is challenging, but it's not insurmountable. We need a mix of motivation and innovation. We need newer and better technologies. We need systems that work for urban India and for rural India. Most of all, we need to feel individually responsible. Better waste management means better public health and greater economic development. And today we've seen innovators who are working towards that goal of zero untreated waste. That's it on this edition of DuPont Presents The Power of Shunya, Quest for Zero, a show that celebrates science and innovation, technologies that could secure our future, human ingenuity that could reduce our challenges to zero. Till next week then, goodbye.